Welcome back to the nutrition module. We are diving now into our macronutrients after we covered energy, and we're covering protein today. Protein being the first macronutrient, as it's going to be our basis for really the one main nutrient that causes a large physiological response for exactly what we want in physique competition, is driving protein synthesis and driving muscle accretion. And other macros just don't have the impactful role like protein. So protein is going to be our first macronutrient when we are building out our diets that we're going to set in place. Then from there, we'll look at dietary fats, then carbohydrates lastly. But for protein, we'll dive into just some basic protein metabolism. We don't need to be full molecular scientists diving down, but we need to know a little bit of how this works. We'll look on the effects of in the research world on hypertrophy and body composition. What are some protein intake recommendations currently put out there by different organizations? What do we recommend? Do you need more protein if you're taking physique enhancing drugs or if you're natural? We'll also dive into vegan versus omnivore protein sources and quality. How should we be tracking or counting these protein sources, whether they're direct or trace in the diet? Then get into meal timing, periodization of protein throughout our contest season, then also safety around protein. So protein composition. So these are comprised of chains of amino acids, which is chains of hydrocarbons, which is really interesting biochemistry, organic chemistry type of stuff. If you studied into that, has a nitrogen group that is attached, hence why we'll see like nitrogen waste like urea when we have digestion and processes occur for these amino acids. And these are the building blocks of all of our bodily proteins. So if you look down to your skin, your organs, all these are comprised of amino acids. And there's 20 main amino acids that are the building blocks and comprise all these bodily tissues. 9 of them are essential. Those are branched amino acids, leucine, isoleucine, valine. And these are the ones that your body cannot recreate on its own. It's just through more technical transamination, deamination processes. But these are the essential ones you must get in your diet. And that's when you start to get into what makes a good quality protein source to consume. And it's going to be one that, for one, has high amounts of the essential amino acids, but also include all the non-essential other 11 amino acids present. Calorie contributions, so 4 calories per gram. Protein turnover, when you are consuming these proteins, it's in a constant state of protein synthesis and protein degradation. So there's protein that's getting put into tissues. There's also a constant turnover of this protein and breakdown that is occurring. And this is what would eventually be your net protein balance. So when you have synthesis increases over degradation, you'd be in positive net protein balance. You're in a more anabolic state, we would say. Or if it's the opposite, you're breaking down more protein than you're actually building, this would be a catabolic state. Now we can look at this little diagram that's on the screen here, just to give that rough idea around the transition from dietary protein when you actually consume it to excreted waste. So dietary amino acids are consumed. They fall into an amino acid pool, which we're going to say this is the amino acid pool that surrounds all the proteins in the body. So we don't store protein per se, like you think of glucose is stored as glycogen or fatty acids are stored as adipose tissue. We don't have this storage facility for proteins. Proteins are built into bodily tissues. There's also some that are kind of circulating around. So all this we could consider our amino acid pool. So our dietary amino acids enter into this large pool that's in this circulation, and they're going to be routed to different places. So some are actually going to go back into bodily proteins. And just to know, your organ systems have the highest turnover amino acids in the body. It's not skeletal muscle. So a lot of you think like, man, I need a ton of protein to drive this new muscle building process. If you think about it, just 1 pound of muscle is 450 grams. How much of that is actual skeletal contractile protein? Well, it's like 70% water. So only like 120 grams-ish is actually bodily protein. So you think about 120 grams, the rate at which we build this tissue, say it's even over a month, right? 30 days in a month, you might only need another 4 grams of protein per day to get that 120 grams for the month. Now, there's also a more costly thing that we do have to account for, but with total body proteins on having to maintain this anabolic state for all the other organ systems. But to context, like when we're trying to build muscle, there's not going to be this extremely excessive amount of protein that's required because of how much protein is actually compromised of your muscles actually compromised of protein. So we have this state of proteins that are in this pool going to bodily tissues, but also those cells are turning over, you're renewing bodily proteins, and you have some protein breakdown. Just like if you have a house and the sheetrock is kind of getting old, you're like, oh man, got to replace the sheetrock, or you got some boards on the outside of the house that are looking a little damaged. You're like, all right, let me replace this board. Same things happens with all of our protein structures in the body. We have to repair, renew them, and replace them over time. So that's the exchange of proteins that could be occurring. Also in this amino acid pool, we're going to have some go through biosynthesis for other nitrogen compounds that aren't going into tissues. So this could be pyphorines, could be nucleotides, creatine, carnitine, hormones. So all these other structures that depend on peptides, right? What do you think of a polypeptide hormone? Insulin, growth hormone, all those are amino acid structures. Then the other part where protein is going to go to is catabolism. So if you don't need protein for bodily tissues or to create these other nitrogen-based compounds, you have excess protein. Well, you just are going to oxidize it and excrete it as urea and CO2. So if you have high urea, so this gets into our lab markers, high blood urea nitrogen, BUN, that's what we see on our labs. It could just be from a high protein intake. That might give you some suggestion that maybe you're over consuming protein if your BUN is really high. Not necessarily a bad thing. We also want to make sure we cover all bases, right? Also it produces more CO2, which not necessarily, I won't usually see high CO2 in labs from a higher protein intake. But urea, BUN, absolutely can. So sometimes people look at kidney function off of BUN numbers, which really could just be that you're consuming a lot of protein.